Hello everyone. Before starting the video, let me tell you the whole idea, the concept of this videos. I'm not here to teach you, but I'm here to be consistent with you. We will be solving problem each and every day. Currently, we are following Fra's DSA sheet and we are targeting a pattern, 2 pointers on arrays. Currently, we have solved 5 problems and today we are going to solve remove duplicate from sorted array. The idea is we will be covering the journey of continuously solving DSA, as well as I'll be sharing the opportunities, not the opportunities for you to apply, but what are the opportunities I've applied and at what stage, what are my experiences till the time we crack a big opportunity. So it's a long journey ahead. I hope you can join me, you may continue with me, and we together solve the problem. So let's hope for the best. Now let's go. So the question is remove duplicate from a sorted array. You can see here 1 1 2. You can see 1 is a duplicate element in this array. So we need to remove this one and we will get 1 and 2. These are the unique elements what we found. And there are two elements which is unique. That's why we need to return 2. Here you can see there is an array of elements 0 0 1 1 1 2 2 3 3 4. What we need to do, 0 is a repeating element, we need to remove 1 0 such that we will get only single 0 here. Then there are 3 1s, we need to remove 2 1s and we will get only a single 1. Simply means we need to remove this duplicate elements and we need to return the number of elements which is unique. So here you can see 0 1 2 3 4, there are 5 unique elements, so we need to return this 5 as an answer. So how to approach this question? So let's say I have an array of nums. So for this, let's create an index I d x, which is starting from the very first element. Now, why I am starting from the first element but not the 0th index? You will get to know. So what do? We will iterate this array from left to right. That means we need to use a for loop. So let's create a for loop. I made a for loop which is starting from first element. Yeah. Now why? Because I'll be comparing it with its previous element. That means if I am starting from the first index, so I'll be comparing this array of I with its previous element. That means array of 0. However, if I start it from 0th index, now in that case, I have no chance of it comparing with the previous one. So we can't have array of -1 now. That's why I'm starting it from first index. Will be continue with -1 till the very last index, and as you know I plus plus. Yeah, this is the concept of my for loop. Now you can see here at 0 I have my I. So what I'll going to do, I will compare this element with its previous element and I'll check if it is unique. If it is unique, let's see how to check this. I'll check if my nums of I, if it is not equal to nums of I minus 1. Yeah, this ensures that we have a unique element. This will ensure we have a unique element. That means this I is not equals to this I minus 1. For that case, if we get a unique element, what we're going to do, we're going to do nums of idx. We'll store it in our index here is equal to what we will going to store in that index, the element which we found unique, which is nums of I, and we will increment this index. Now I'll show you what I have written here. Let's say I have a I here, I have a nums of I which is 0, I'll compare it with the previous one. So let's say 0, which is the previous index. Is it following this criteria कि 0 is not equals to 0? No, it is not following this criteria. In that case, we don't have to increment this index. It is 1 only. So let's move our I from this part to here. Now again, compare it with the previous one. That means 0 and 1. So we'll compare. The previous element, which is 0, is not equals to, sorry, okay, we have 0. Is it following this criteria again? Nums of I minus 1 is not equals to nums of I. That means 0 and 1. Okay, these are the unique elements. In that case, that means this one will store it in nums of index. Okay, now we will do index plus plus. That means index from 1, it will become 2. Okay, now let's move our I from here to here. Again, we will check 1, which is the previous element, and this I is at 1. Is this unique element, is this following this criteria? Nums of I is not equal to nums of I minus 1. No. So we'll simply move I from here to here. Again, check. This is my nums of I minus 1, and this is my nums of I. Are both unique? No. So we'll move I from here to here. Now let's check. This is my nums of I minus 1, which is this part, and this is my nums of I. Are both unique? Yes, both are unique. In that case, I will increment my 2 to 3, and I'll store this 2 in my nums of index, which I'll do is equal to nums of I. Simple. Now let's move this I from here to here. Again, check. 2 is not equals to 2. No, that's not the case. In that case, our index will remain 3 only. We'll move our I to this part. Now we'll check. 3 and 2 are both unique. Yes, they both are not equal. In that case, I'll store this 3 in my nums of index, and I'll do index plus plus. That means from 3 it becomes 4. Simple. Now I'll move my I to here. Now you can see the both are same. In that case, our index will remain 4 only. Now move I to the very last index, which is 4. Let's compare it with the previous one, that is 3. Now check, are both same? No. In that case, it is following this criteria. That means we will store 4 at nums of index, and we will do index plus plus. That means from 4 we are getting the answer 5. Now if we move more ahead, no, we can't move. That means we reached the last index, which is n minus 1. Since Java follows zero based indexing, that's why we reached n minus 1, which is the last index. Our answer is 5. Now let's try to use this concept